Okay, so the objective of this tutorial is to train Tesseract to recognize properly a new font. Like, it recognizes most of the fonts by default on the English trained data, but not every font. And I was having some trouble recognizing this specific font, which is the PUBG one. And you can see it has very cocky numbers, and it was having a lot of trouble to recognize it. So this is one good example of why you would want to train Tesseract for a new font. So the thing is, to train Tesseract, we need training data. And Tesseract folks were kind enough to provide us with a tool, the testtrain.sh file, to train such data. All these tools, including the testtrain.sh file, can be installed via Git. You just need to clone the repository and follow instructions to install the training tools. So I'm gonna suppose you have all the tools installed and the instructions are thorough enough, so it's quite easy to do. So with the training tools installed, you need to get the font file you want to train Tesseract with. So this is one good example. It's just a true type font file, it's just a TTF file. It's very common and very easy to get over the internet, any kind of font you want. If it's a game, if it's something, just Google it. Most probably there's a font file for it. So you need to get the font. So I'm gonna show around the structure of this folder I got. And the first one is this fonts folder, which will hold all the fonts you want to train Tesseract with. So in this case, I just got the PUBG font, and that should be good. And with the font in mind, we can generate images with text. And as we are generating the images, we know what text we are writing on the images. So we can provide Tesseract with an image file that we can provide Tesseract every character, every position of every character, and which character it is, which is called the box file. It's called the box file because it gets the image and creates boxes around every character and instructs Tesseract which character is that, and the exact positioning and boundaries of the character. So to generate this file, you need the font, and we do have it. We do have the PUBG font. So now we need to generate the training data, and to generate the training data, we need the testtrain.sh file, which you get from building Tesseract from Git and building it with the training tools, which should be a couple of make instructions, should be easy enough. So I got this handy dandy little shell file that has some arguments in it, pre-compiled, and I'm gonna use it as a starting point. It will be available on a GitHub page I'm setting up, and I'm getting on the description of the video, so you can use this file and as you please, and this folder structure I created, so you can see what it uses. So it specifies where to look for the fonts, and it's the font there, which will be this one. It specifies which font to use, and it just need to get the font name on here, which most probably you can get from the file from the file itself. So, and there you go, agents FB condensed. So after getting the font name and specifying those, you need to specify which language it is, and this parameter will be used to determine which configuration files for the language, which will dictate the words that will be used to train Tesseract with, the punctuation, the numbers, how they are formed, dates, and such. So you specify which language is it. I'm training on top of the English trained data, so it's English. I'm gonna generate only line data, which is for the most recent version of Tesseract, the version 4 of LSTM, right? And you need to specify the length data, which has a lot of information about the language itself, so punctuation, dates, and such, which it can be just cloned from Tesseract OCR GitHub repository page. So you just go to LangData LSTM, which is the LangData for the newest version of Tesseract, and you just clone it. Okay, so I'm gonna use SSH. Not giving me an option to clone SSH. Okay, so there you go. I'm just gonna clone this repository here. Should be good. So I'm using the LangData LSTM as for providing the LangData information. And then we also need to provide a lot of information about the network itself, that within the Tesseract repository also. So go to Tesseract and also clone it. And there you go. Let me clone this in a new tab. Oh, not wget. Okay. Should be fast. Yep, it is. So you can see on the Tesseract, it has the Tessdata folder. And what we actually want is the configs folder with all the configurations. So, and this will have all the configurations necessary for testtrain.sh, the file we are using to generate the training data, to actually generate using the Tesseract command line. And LangData will have all the language specifics information. SaveboxDiff will save just a representation of the training data that we can actually see and actually evaluate by ourselves if the training data is good or not. Max pages is to limit the amount of pages generated for training data, and by default it's 4,000 and it takes a huge amount of time. So for the sake of the tutorial, I'm using 10. I found that the number 200 works well. It doesn't overfit a lot, so I think 200 is a good number to start with, and it's a decent sweet spot. So I'm training with only 10 pages, and I'm just outputting all the information about the training data on the train there, which I created here. It has this train like an empty train there, and it should be good. And you can see in the LangData we have the eng folder, which is the language we specified, and a lot of specific information about the language itself. So with all of that set up, we can just run this script and it should start generating training data. Oh, I got this wrong. There you go, with the wrong font. And it should start generating the data. And it will first generate the 10 pages, and then it will fail. Oh, right. Okay. So now we also need to download the train data we want to fine-tune. So here the objective is to fine-tune a previously trained Tesseract network with a new font. So you go to Tessdata. Actually, you can go either to Tessdata Fast, or Tessdata Best. I like the best the most, which in my case, we don't need a lot of performance, we just care about accuracy. So this is the most accurate train data possible. You can just right click it and copy the link address, and you can go to Tesseract Tessdata and then just download it, and then you should be good. Okay, it's saved. There you go. So let's try generating the training data, and it should be good. So this file is very verbose. It tells you a lot about everything. It also failed. Data error open data file. Oh, right. Probably haven't set up it properly. Sorry. So let's go to Tesseract OCR. There you go. Find the English training data and get it raw. Get here. Not there. Let's go. This data, and there you go. That's better. Remove the old one. let's just do error. Training data. Good. There you go. So we generate all the training data, and then it's just finishing, and we can actually get it and realize what was generated. So it's basically a Word file with a bunch of text, and it generates randomly skewed and randomly. You can see it's kind of imperfect with a lot of without anti-aliasing at all, and you have a lot of imperfections in the font. So the Tesseract network doesn't overfit with the data. So you can actually see that it has a bunch of pages by going with the proper document viewer. You can see generated 10 pages, and it can go up to 4,000 if you want. But I found out that 200 is the best, and 10 is enough for this purpose. And it takes a huge amount of time with a lot of pages. So we generated the training data, that's good. So we can actually run a evaluation command now. See if I got it. I think I got it here actually. Eval, yeah. There we go. So let me use. I'm gonna evaluate the current. So it's Tesseract, Tessdata, and train data. So this is the file we downloaded from the Tessdata best repository. So this is the best train data we got on English. And what I'm trying to do is get the training data I just got, which will be on the train folder. Right, yeah. Oh, sorry, no, this is actually correct. So this is using this model. Oh, actually, I need to get the model out of the train data, the English train data. And to do so, I also need this script. Extract from our own, yeah. There we go. So basically what this does is I'm gonna extract the model out of the train data file we downloaded, so we can actually evaluate this model. So let's extract it. Should be good. We should have the English.lstm file here, and we can actually evaluate the model we just extracted. So let's see by default what is the accuracy of Tesseract without language. So I'm using the best training data as data information, and I'm going to use the files I just generated on not eval though, on train. So you can see the train folder has a bunch of files. This one is the box diff we wanted to save. Actually, you visually see what's happening, and there is the training files that basically has a line saying that Tesseract should use this file, which is this one, to train and or evaluate or whatever. So, and this is the box file I mentioned. It has the boundaries and which character it is for the image we generated on the diff. Okay, and the LSTM file is like the diff file but encoded for Tesseract. So let's try evaluating this and let's see how it performs. Okay. So it tries recognizing the 10 pages of text we just generated. You can see there's the truth, that is ground truth, so it gets from the box files and such. And then what OCR detected from basically the Tessdata best English.train data file. So you can see it has a bunch of problems. It's mostly with numbers from what I've seen. But you can see that the one got mistaken by an exclamation. We have a lot of problems as O's for U's, and this happens very often, and it was just not enough, right? So you can see here it's just failing very often, and this was not enough for my case, for my use case. So you can see it has an error rate on the character of 2.8. The problem is, if you want full accuracy, you can see like the 9 going for the 3 here. If you want the total accuracy on numbers. You can see 0 for D, and 3% for each character will lead to a lot in a somewhat number packed document. So 3% of error on characters was not enough for me, so I needed to train Tesseract with better with a new font that it would just improve the overall recognition, right? Okay, so we generated the training data, which in this tutorial we also use to evaluate, which is it's not a big deal. Okay, so now we need to fine-tune the ENG, the LSTM, which is the model of the English best trained data. And I'm gonna output this on this folder here on output/PUBG, okay? And the PUBG is actually a prefix. So we just prefix every file with PUBG and outputs the actual folder, which would be this one. I'm gonna use the training data as the best, the Tessdata best one as a beginning point, right? And then I'm gonna fine-tune it with the training file that I just generated. I'm gonna use 400 iterations. It takes a long time, like every 100 iteration, and I found out that around 2000 iterations is a good point, that it doesn't overfit a lot, but it does, right? So 400 is for the tutorial purposes. It should be good for most cases, but if you find it's not yet as accurate as you want it, you can go for more iterations. But basically, the more iterations, the more you will fine-tune the English.train data file, and it might be too fine-tuned to the point that it only recognizes your new font. So this should be a parameter you should play with and find out what works best for you. Okay, so I'm just gonna run the LSTM training tool. I'm gonna continue from the model that I extracted from the English.train data from the Tessdata best repository. I'm gonna output here, use the file again that I downloaded, yada yada, and use this training file I just generated with 400 iterations. And with that, we should be good. And let's see, so it starts with a very high error rate, and it goes improving it with time. So the main objective here is to go down from 3% of error rate to go down to around 0 point something, and it is achievable with more pages, not only 10, and with more iterations. You can see on the first 100 iterations we are already 1.5 error rate, so this is already better than the baseline we got from the Tesseract best, right? Tessdata best repository. And it goes pretty fast within the first 100 iterations, and then it starts converging to some model, and then it starts going up and up and up. But 400 is a good sweet spot, that it doesn't converge away of the global minimum, right? So there you go, it's going the lower and lower. So you can see with only 10 pages and with only 300 iterations, we are way better already than we were before that. Okay, and there you go. So finish with 1%, and then that should be good. If we go around 2000 iterations, it drops really low. So this should be good even. Okay, so let's try evaluating this model. The one last step you need to do is use the combine SH, which basically stops the training. It continues from this checkpoint that was basically the best model Tesseract got. Alright. Okay. And then we use the training data we downloaded as the base to merge. So we are basically merging this on this and outputting this. So outputting the model on PUBG.train data. And you can see on the output, you can see a lot of PUBG prefixed files. And Basically there's a bunch of checkpoints, and the last checkpoint with no, so this is the error rate, so it's 1.137, 1.097 and such, and this is the best final model that we got on the training step. So let's just combine it, and we should have a train data file available. So if you go output and check it, we have now a PUBG checkpoint file. And basically, sorry, PUBG.train data file. And basically this is a file you can use to, you just freaking use it, right? So on the eval, now instead of using this model, let's try using the one we just generated. So let's use PUBG checkpoint, which is again the best model the training step was able to produce. So let's evolve it again with the new model, and let's see what accuracy we get. Okay, like it won't never be perfect, honestly. It will get you very little errors, but 100% it is very hard to achieve, but it's very close. It's definitely very close. You can see I'm not being able to spot any errors right away. You can see it's getting the numbers pretty much spot on, and this is only with 10 pages for 100 iterations. You can go way beyond that to get way better accuracy with your font. So the thing is, the documentation, so we got at 0.37, it's way better. So we got down from 2.8 to 0.37, so we improved like 10 times. So congratulations to us. There you go. And so the documentation regarding training Tesseract is not very big. There's not a huge amount of documents to help us. We got some tutorials, but it doesn't cover every case, every use case for Tesseract. So I think this is a very good use case where you want to train a new font that you just don't have it previously trained for, and you don't want to train it from ground, train it from scratch, which may lead to a number of errors. So this should be easy enough, and this is quite fast, as you could see, and we dropped the error rate a bunch. So I think this discovered this use case of needing a new font, and I hope you enjoyed. All the links on the Tesseract OCR repository and my repository with all these scripts and such. It's on the description, and thank you for watching, and any questions please leave down in the comments below. Thank you.